we have already done some work with parabolas when we studied the quadratics, and so you guys are used to like y equals x squared or y equals the quadratic equation is ax squared plus bx plus c. That's kind of standard form, and that will generate a parabola or a parabolic curve is called. And so what we're getting into with conics is literally if you take a cone and we can slice at different spots. So if we slice along this side, the face would be the parabola. If you slice exactly parallel to the base, the circle base, it would be a circle left on the face. And if you go this way through two of them, you have the hyperbola that we'll study in a little bit. And you'll get that. So this is what we're talking about. Is we're taking a cone. If you slice it, you could have a circle, an ellipse, a parabola, and a hyperbola. And then over here, they're showing you kind of the angle. So if you're slicing, this red thing is parallel to the base circle. The face right there where you cut it, the face would be a circle. If you have a slight tilt to that thing, you're going to get this oblong circle inside there. That's where the face would sit. That's an ellipse. The parabola is when you cut up here, you can see how it's opening up that way. And a hyperbola that we'll talk about in 10.3 would go through both of those columns, and that's called hyperbola. It's like two parabolas pointing in opposite directions.
This helps so much.
Oh, good.
It really did.
So, what we're talking about today is this definition of a parabola. We're adding a few more things to it. The other formula that you guys might remember is what we call the vertex form. Where you could look at it and say that's my H and K, that's where the vertex is located and everything, right? Okay, so parabola set about points in plane that are equidistant from a fixed line, the directrix and fixed points, folks. So there's a bunch of math mumbo jumbo. The things that we're adding today are what we call the directrix and the focus. Now the idea is, why do parabolas have the shape that they have? Why are they sometimes that get kind of wide, or sometimes they're tall and skinny, if you will? And it has to do with the relationship between what we call like D1 or D2. So if we draw or pick any point on the parabola, draw a perpendicular line to what we call the directrix. That distance can be then copied and it'll go into the focus, and that's how you can get that shape of the curve. So we're going to be able to find where the directrix is, where the focus is. You don't really have to know anything about the D1s and D2s there. So the way I put the packets together, you guys have the two facing you. Be able to look at one at a time. But the standard form of the equation of a parabola is given now. We're going to use this form as we go through the chapter 10 stuff. We're going to put the squared quantity on the left and what I call the single power quantity on the right. So yes, this is the third form of a quadratic, or this parabola that we've looked at. There are, kind of standard form, vertex form, and now this one. If x is being squared, you're talking about a vertical parabola, and that's probably easy enough for you guys to remember because you guys know what y equals x squared is. If I say graph y equals x squared, everyone's going to just draw it. So remember, if x is being squared, it's up and down. If y is being squared, it's left to right. We're going to use the distance p, which is the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. That'll make more sense as we actually do some of these. So here's some information that you can look at and refer back to it. But it just shows you the difference between ones that are going up or down and ones that are going left or right. I'm going to skip the first one and come back to it. So we're going to start with number 2 here. We're supposed to draw everything, so we're going to first of all, let's find the vertex. Everything for the parabola builds off the vertex. So where's my vertex? Negative 1/2, positive 1. So about right there. Negative 1/2, comma 1. No. Really wish that was. So we have negative 1/2, 1. That's where the vertex is. Now we're going to find the focus and directrix. And those are new things for us today. And we're supposed to find the axis of symmetry. Let's actually find the axis of symmetry first. Axis of symmetry. You may see, people might label, AOS, axis of symmetry. Well, how do we already know where the axis of symmetry is located? It's going to go through the vertex. But is it up or down or left or right?
Up or down.
Because x is being squared, I already know that the axis of symmetry is running up or down. And so let's just go ahead and label on here. It'll be x equals negative 1/2. It's a vertical line, so you label it with x equals some number. All right, then we can move on to the focus and directrix. Those are new things today. So what we're going to do is anything that's the coefficient in front of the what I call the single power. This is really like y minus 1 to the first power. The stuff that's in front of it is always going to be set equal to 4p. So that number is a 4. So we set 4p equal to 4. Divide by 4. P is positive 1. Now I don't have to write positive 1. But whatever that number is, positive or negative, will tell me if this thing is going up or going down. Because it's positive, I know I have a parabola that's opening up. Right? So I'm just going to draw a parabola right now that's opening up.
It doesn't matter.
There's nothing in here. There's nothing in here about the intercept, so I'm not really worried about the shape of it right now. So I'm just going to draw this parabola opening up. Then that is the distance from the vertex to the focus. So go back to your vertex, and we're going to go up 1. How would you label that dot? It's the same x value, still on that line, but now you are really adding 1 to the y value. So the focus right there is negative 1/2, comma 2. You add it to the vertex. Now, you know where the focus is going to be located because that parabola, wherever it is, it always wraps around the focus. So even if it's going to the right, it would wrap around it that way. The directrix will be in the opposite direction. So if you went up to the focus, you will come back down to what we call the directrix. And so coming down 1 from the vertex will leave me at y equals 0. So that's the directrix. So you have 2 lines, directrix, axis of symmetry, and we have 2 dots, vertex and focus. Any questions on that one? Yeah.